Now we have the transport equation. We also have the photon fluence defined and photon flux. And we also have the P1 approximation of L and also the source S. So next thing we will do is we will do the integral of each term in transport equation over the direction omega hat. So that will be 1 over v times the integral of partial derivative of t of L, and then we do the integral over omega hat. And the second term of transport equation is the gradient of L times omega hat, and then we do the integral of this term over omega hat. Next term is mu t times L, and then we do integral of this term over omega hat. On the right hand side of the transport equation, the first term is mu s times integral of L omega hat prime times f omega hat prime over omega hat prime, and then we do the integral of this over omega hat. And then the last term is the source s, and then we do integral of s over omega hat. Then we will further organize this equation. So the first term, the integral and the derivation is interchangeable, so that we can do integral of L first, and then we do the partial derivative over time t. And then the second term, the gradient and the integral is also interchangeable, so we put the gradient outside and then do the integral of L times omega hat. And for the next term, mu t is a constant value, so we can put it outside of the integral. So that will be the integral of L. On the right hand side, mu s is also a constant value, so that we can put it outside of the integral. This. So from the definition of photon fluence and photon flux here, we can further simplify the terms in this equation. So for the first one, the integral over omega hat of L function, this is actually is defined as photon fluence phi. The next term, the integral of L times omega hat over omega hat is actually defined as photon flux J. So do the next term, it should be phi. And then for the last term of this equation, it should be the same way of the integral of L over omega hat. So it should be S0. This term, the first term on the right hand side of this equation, is a little bit complex. So I will explicitly derive how to simplify this equation. So from here to here. So the first thing I want to do is to insert the P1 approximation of L. So that would be like integral of 1 over 4 pi phi plus 3 over 4 pi j times omega hat prime times f omega hat prime d omega hat prime d omega hat. And next, I would say we multiply f into each of the terms inside of the parentheses. So that will be 1 over 4 pi phi times f omega hat prime plus 3 over 4 pi times j times omega hat prime times f omega hat prime and then d omega hat prime d omega hat. And those are all inside of the double integral. Next thing we can do is that we can do integral to each part of the terms inside of the integral sign. So the first one will be so actually 1 over 4 pi is just a constant value, so we can put it outside of the integrals. Phi function itself doesn't depend on any direction, either omega hat or omega hat prime. So we can treat it as a constant and then put it outside of the integral signs. So what has been left is the integral of f function omega hat prime d omega hat prime d omega hat. And the next term, the same way 3 over 4 pi can be taken outside of the integral. J function is also doesn't depend on the direction of omega hat or omega hat prime, so we can put it outside of the integral. So what has been left is the integral of f omega hat and omega hat prime times omega hat prime d omega hat prime d omega hat. So next one comes to our first assumption, which is the tissue we are considering here is actually very scattering, which means that most events happen in this tissue is scattering rather than absorption. So in mathematical term, it means that mu s over mu s plus mu a is approximately equal to 1. It also indicates that the integral of f function of omega hat prime over the direction of omega hat prime, that should be approximately equal to 1. That is indicated by the fact that the photons coming from all the directions other than omega hat. Like most of them are scattered, not being absorbed. So the F function is the possibility that a photon is coming into the tissue in the direction of omega hat prime and then being scattered into the direction of omega hat. So that means the integral of F function over all the directions should be equaling to 1. So the first term can be simplified as integral of 1 over omega hat, and that is from our fact sheet. That should be 4 pi. That's what how we simplify the first term. And then the second one is almost the same. So the two integrals actually can be changed, is interchangeable. The two integrals are interchangeable, so actually we can do the integral over omega hat first. In that sense, omega hat prime here is just it's not depending on omega hat anymore, so we can take it out here, and then we do the integral of omega hat, and then we have the integral of omega hat prime outside of everything. And the same thing here from our assumption 1, this term should be 1, and then what has left is omega hat prime, and the integral of the same omega hat prime. And then from our fact sheet, that term should be equals to 0. So the second term here is actually 0, and then the whole term here is because 4 pi canceled out, so that we only have 5 here. So yeah, that's how we simplify this term. At the end, it should be phi. So that's reorganize this equation and see how it looks like. So that should be 1 over v times the derivative of phi over t plus the gradient of j plus mu t times phi equals to mu s times phi plus s0. Since mu t equals to mu s plus mu a, so that we can actually further combine these two terms. So that will give us 1 over v times the partial derivative of phi over t plus the gradient of j plus mu a times phi equals to s0. So actually, this function is the scalar part of our transport equation.